Good afternoon, everybody. I'm so pleased that you are joining me today with the idea of biodiversity, which is a cool word in the sense that you can ask the question, if we have a lot of species represented in our ecosystem, then we are more of a robust ecosystem because as challenges and stresses come on the scene, then you can hopefully find species that will survive and maybe others will drop out. And it's a measure or a metric of, or a barometer, if you think of it that way, of how well suited your lake is for the future. Biological mapping is a word that I started to use when I thought about how we start to look for things in the water, specifically Eurasian water milfoil. And when we look, we often find more than what we're looking for. And so when we think of biological mapping, we find something, and luckily with the way we do the searching and the survey work, we have location data to go with it. So why not do the mapping? This is an example of a canvassing of Little Glen and the trench of Big Glen under the Narrows, where if you take a drone with a camera, 4K camera, and you follow these flight paths in parallel fashion across what I would call the active biological zone of Little Glen and a piece of Big Glen, that you have a total of 24 miles of flight time, and you have all this wonderful imagery. And then you have to ask the question, can we use this imagery in an effort to try to find not only Eurasian water milfoil, but what else is happening in the lake? And from that survey work, you can look at the optical imagery and say, oh, this looks kind of interesting here or there. So what you're looking at here is 38 sites that we decided would be interesting to look at based on the optical flight pattern of Little Glen and the trench. We'll call it the trench of Big Glen. And we looked at all these scans and decided these would be the places we want to do some ROV work, remotely operated vehicles underwater. So from those 38 sites, we created a spreadsheet where we listed each of the sites, 1 through 38. We put the GPS coordinates and we made some notes as to how we were going to look at that data. And then when you take a look at not just Little Glen and the trench of Big Glen, we decided in 2025 to expand our search. And so you can see these flight paths also include portions of Big Glen at the drop-offs when you go from the shallows and the shoreline to where the plants really start to grow. We also canvassed completely in 2025 the Fisher Lakes, and we even did some kayak canoeing dragging a GoPro camera, and we funneled through all of the upper reaches and the lower reaches of the Crystal River looking for whatever might be there. And a big thanks goes to this guy right here, Dennis Wyan from Zero Gravity. And using his underwater ROV with a GoPro attached to it, we were able to amass a lot of data. And we combined that with an aerial drone that helped guide the direction and the path of the underwater ROVs. So these two pilots, a drone pilot and Sean, who operated the ROV, they could work in tandem to make sure that in our points of interest, one of those 38 sites, we were doing a good job of collecting as much optical data as we could. We also used a GoPro on a pole, in this case, a pole with an underwater camera housing that surrounded the GoPro, which allowed for a live feed through an HDMI cable so that when this recording was happening, we could also look at what the GoPro camera was seeing in real time. And then here's a chance to show you some of the apparatus on the boat. So as this GoPro on a pole moving the boat in a given direction in a grid pattern or in a transect, we were able to see immediately whether we were picking up what we wanted to look at or whether we were off the track, in which case we can make adjustments. And we can also use the conventional painter's pole with simply attaching that to a GoPro and putting that under the water. And we can also take the GoPro and swim with it, which is a nice way to find what we're looking for and archive the snorkel. And then we can also attach it to a mask. So these are all ways that as we swim on the drop-offs and we do our recordings, that we can make sure that we have indisputable, archivable information that really is providing a great baseline for our watershed. So this is an example. If we did a rolling of the video at 300 feet above the water line, I'll just give you a quick orientation. The upper left of this screen gives you an idea of the flight path for this particular drone survey on Little Glen. The yellow circle shows where the camera is and this drone. And then as it moves forward, these GPS coordinates are constantly changing so that when you take a screenshot and you see something of interest like this spot, it almost looks like a freckle, that you can actually combine the location of that site or points of interest with the exact GPS location so that when you do the ROV work and you crisscross this patch of what looks like aquatic plants, that you have geolocation information at your disposal. So the other widgets that you see in this screen is the compass bearing for the way in which the drone is moving across the water. You also have a distance instrumentation here where you can see that it's just starting in this flight path, and when it's done, it will have covered 1.6 miles. And then you can see the altitude ranging anywhere between 310 and 300 feet above the water line. And this entire screen probably, takes a lot of time for somebody to crisscross this with a boat or maybe even with an aquascope, but you can actually get a fair amount of coverage with this one screenshot at 310 feet above the water line. A question often comes up, well, why don't you fly it at 150 feet or even just 10 feet above the water line? And you don't get as much efficiency with the coverage, so we like to think of 310 feet above the water line as the sweet zone. So when you go underwater with an ROV, you can capture imagery like this. This is just one of a million screenshots that can be taken at any point in the active mode of the video. In this case, you can screen shoot and actually see a lot of the plant characteristics that are presented here so that you can do positive identification of the plant in terms of its species. Here's another screenshot. Imagine being underwater with an ROV and traversing across this rich bed of aquatic plants in Fisher Lake, and you can literally count the number of species. And then if you're good at it and you've got enough botanical knowledge and you have the help of a handbook that tells you what the names of these plants are, you can begin to not only identify the species and add to this concept of learning more about your biodiversity, but again, remember, you've got exact GPS coordinates for every view that you look at. And I would just ask the question here as we take a minute to look at this slide. How many species of aquatic plants do you see, and what are their names? And as you do this more and more, as you get acquainted with your lake and your aquatic plants, that you become much better at being able to make a list of what's there. We also did a combination of, well, where are these points of interest located in relation to where Eurasian watermilfoil might have washed up on shore. So in this case, we're showing you a combination of the flight paths And we're also showing the bathymetric overlay that can be put into a mapping system so that you can, if you've got EWM always showing up in a certain depth in your lake, that you might start eliminating looking at it in shallower water and always looking at it from where, or looking for it in a place where it might be in this, what we call the ideal location for Eurasian watermilfoil. You'll notice these lime colored transects that come off from the loading ramp or the boat wash station that Glen Lake has. We only have one of those, which really helps us control this idea of a Eurasian watermilfoil. We boat wash everybody that comes and goes. So we had a wind direction that was noted when we had EWM wash up on shore. So that helped us decide to add more survey sites to the 38, for which we then found EWM very quickly thereafter. And then we also have an overlay that can be put into Google Earth dealing with the hardness of the bottom. And so this map of showing you the soft spots of where the bottom might be very mucky and filled with silt versus the places where it's hard packed sand, that further can help you understand more about your bottomlands. And these pins that you see here are where we found EWM, and they seem to favor the same sort of hardness of the bottom. We also did a bio-volume plant density mapping system that would help us in learning where we can find more species of plants and not spend our time looking for places where you don't find anything growing. One of the other tools we used is this concept of an orthomosaic map. It's basically stitching together maybe 150 individual still JPEG images that are put together in such a way that you have a much larger area that ends up being a single image. And these green pins here show additional sites for where we were picking up species in our biodiversity project, as well as looking for EWM. And we were thankful to find that in all this ROV work in Fisher Lakes, using this orthomosaic, we were happy to find that there was nothing to worry about. And we were also picking up a lot of information about our bottomlands. If you take a look at the pins and where they're selected, and you can see that the areas of highest contrast seem to be where we were focusing our work, or maybe even a place where there might be some structure in the bottom where EWM might have landed and taken root. One of the cool things about taking the initial optical data from the high flyovers at 300 feet is that when you start taking an area of interest, this would be pin number or site number 39, that when you boost the contrast and work with it much like you would a photograph where you want to see more detail, that this allows us to not only find more interesting areas to rule in or rule out, but also gives you an idea that looking beyond this red circle, you can see that it looks like EWM has only landed in one area. So that's where we spent our time. This turned out to be our largest Eurasian watermilfoil site at 1,600 square feet of area. And one of the nice things about mapping your plants is you can actually use RTK positioning in the geo tagging of this particular site and draw a boundary around it. And then with Google Earth, you can actually calculate the square feet, which is important for if you're going to cover it with burlap or treat it with chemicals, that you've got to have that information anyway. And here you can see another site, area 51, not to be confused with 39. That was our largest site. And once again, with enhancing the imagery, you can see where to look and where not to look. So we ended up with, at this point, I think we're up to 94 sites total. And these are going to be what we call the baseline study sites, so that when we go back in years coming forward, that we will be able to know exactly what's there. And the nice thing about this is that we can add more pins and add more information. And once we do, we can take a species, one of the species out of the 20 some plus aquatic and native plants, and we can actually show you a map of the distribution of northern watermilfoil. So for an example, we have a total, remember, of 78 pins or sites, and northern watermilfoil did not show up in all of them. And so this Google Earth mapping software allows you to show where it does show up and where it's growing. And you can do that with any species that we actually found in our studies. Here's another example of looking at the bottomlands through some pretty clear water and in shallow water, because you can see there's probably 1 to 2 feet depth here to the right. But as you hit this drop off, it's probably 7 or 8 feet to the left of this red arrow. And so you can see places where we want to look for species, and sure enough, they show up here. We can also see from the air. We don't have to necessarily fly over a spot with an underwater ROV. We can actually see some of this from the air. So we know that northern watermilfoil is heavily concentrated in this small inlet on Fisher Lake. So what we do is we kind of take a look at this formation and this texture and tonality and ask the question, where else might it be? So you don't necessarily need all the technical information and equipment that we're talking about. You could just go there in a boat and with a GoPro camera, take a look at it and count the species. Here's another example of looking at a bottomlands, and it looks like Little Glen. I can tell because I go up here and look at my GPS coordinates, and we can say that largely there's a fair amount of area in this view that you don't have to go looking for species. And so then you can really make good time by looking at where you think there's areas of highest contrast. For an example, if we, out of the 24 species of aquatic plants in our watershed, you wanted to, like we did with northern watermilfoil, ask the question, so where is bladderwort in your bottomlands? And so the way Google Earth will work is it'll show you the exact locations of bladderwort, and if you want any species with a map attached to it with a geolocation, doing these kind of surveys and making note of what's growing where gives you this power of a baseline study for aquatic plants. Again, EWM was only found in 3 of the 78 sites. We're happy to report that. And it's not to say that we have a final determination on whether or not this is the total, but we think that if we do a good continued search, and we're never going to stop searching, that we'll probably find more, but at least we're feeling good about out of the 78 sites, we only found 3 sites with EWM, which means we're probably at the beginning of an infestation. And if we tack it early and get a great response with burlaps, we're going to be able to come back and survey again and not find any. Another species of aquatic plants that I like to show is the fernleaf pondweed. This is a case where you have, of the 78 sites, a subset of not only the sites, but also the locations where they are growing. And one of the hopes I have in this baseline study is to try to understand plant associations. So if you think on land, you think of hemlock trees growing side by side with American beech and sugar maples. On the other side of the equation, you might find that beach grass always tends to grow next to or side by side with sand cherry. So what we're hoping to find in this study of aquatic plants is what's the, if you find EWM, is it always associated with other aquatic invasives, or natives, I should say? And if so, what are those plant associations, so that we can be even working on a more higher degree of success when we try to find something that we're looking for. We even track the fish. Fish go with the concept of biodiversity. And each time the ROV went down and we saw a fish of a certain species, for which we found, I think, 9 or 10 species of fish, that we can then map them so that we know where they hang out. So this is a specific species map for smallmouth bass. I could generate 8 different or 9 or 10 different species of fish that are all mapped out according to where we found them in the ROV work. This is an example of a screenshot where we were at a particular location in the Big Glen Trench area. I believe this was maybe site 37 or 38. And when you take a screenshot like this, you can actually get a feel for not only what's growing underneath, like in this case, we have some sprigs of northern watermilfoil, but we also have fern leaf pondweed. And apparently there's an association with fish species. So we can arguably say that this is a healthy crop of rock bass. And sometimes when we find rock bass, they're always seemingly associated with this particular aquatic assemblage of plants. So largemouth bass was also mapped out in our 78 sites, and you can see with these pins exactly where they like to hang out. And then we even mapped the freshwater sponges, which grow on the bottom, and they're often associated with plants. And we didn't know how much we had in the way of freshwater sponges, but in this case of the 78 sites, we found a few in the Crystal River and a couple in Little Glen. And then if you take a white sucker of the 78 sites, they didn't show up in a lot of our ROV work. We've since found them in our additional sites, but once again, you can see the power of getting underneath the water line with an ROV, not just looking at plants, but looking at all kinds of species. And one of the other things I like about Google Earth and making note at each site as to what we see is that you can, for every pin on a map, you can point it with your cursor and up pops a submenu for which I populated this information. So an example, if we're in the cut between Big Glen and Fisher Lake, and we're dragging a GoPro camera next to the boat, and we put record on it, and then we come back and run through and scrub the video, what did we find? And so here's a list. We saw sago pondweed, Cara bushy pondweed, alternate leaf pondweed, clasping pondweed, water celery, Illinois pondweed, world milfoil, fern leaf pondweed. We found crested arrowhead, northern milfoil, blunt-nosed minnows, log perch, and pumpkin seeds. And that's, to me, is that's pretty cool. So if you think about it, going to any one of these 78 sites now, we have entered into the mix exactly what is not only growing in a given location, but what's living there as well. We also found value in taking these images because as you scrub the video, you'll find that there are sometimes diseased fish. Like in this case, we have a rock bass and it has a growth growing on its side. It looks like perhaps some kind of malformation of the tissue of both the skin and maybe even the muscle tissue underneath. And it's always fun to be able to say, well, okay, what is this that we're seeing? And so I took this shot and sent it off to Heather Hedinger, our fisheries biologist, and said, this is what we're seeing on some of the rock bass. What can you tell us? And so we can not only find and locate and map aquatic plants and fish, but we can also gain information that we weren't necessarily looking for that we actually see pop up in the ROV work. This is a more concentrated, blown up view of how we looked at Fisher Lake from an aerial drone survey. This was done in the fall of 2024. And one of the nice things about doing something in the fall like this, We can take the spring and say we've got a list of projects where we have a 16 or 17 additional study sites that we want to send the ROV down in about the time of June or July, so that when these plants grow, we got a good visualization of what's there. And that's always a combination of doing a fall survey where the plants are big, they're obvious, the points of interest are easily selected, and then in the spring, summer, go down and look and see and make a list of what's living there. So these were the sites we took this summer and looked at every single site. And so once again, take your eye for just a minute. I'll put this slide up for a few minutes or a few more minutes, but take a look at the bottomlands. This is what we call Little Fisher, and there's an area that's scrubbed by motors that hit prop. They have prop digs in this area. You can see some more prop digs here. This might be a place where if you have disturbances in the bottom, that you might find something in the aquatic plant world that is more invasive or maybe even more aggressive that might colonize these scarred areas. But we found areas where there was undisturbed bottomlands, and we used them as a way to determine what's there. This is another example of where I thought maybe since our lakes are pretty clear, if you take all of Big and Little Glen and the Fishers and the Crystal River, the water transparency is pretty high. And so it allows us to do these aerial drone surveys. And so I challenged Dennis at Zero Gravity to take a look at and fly over Brooks Lake, which is not a very transparent lake. It's filled with a lot of aquatic plants, but it also has a fair amount of plankton in it. And I didn't think the light penetration would be enough to see where we might find some biodiversity. So what we did is we have a concern about Brooks Lake because there's two canals that are connecting to the Big Glen, and so we don't want anything invasive here to show up in Big Glen by way of these connected waterways. But here's the flight pattern. Again, these dots represent individual JPEG images. So when they're stitched together using some software that Dennis has, we can create an ortho mosaic like we did in Fisher Lake. And so this is the ortho mosaic in its final form. And I don't know if your eyes train well enough, but there's a spot in the middle of Brooks Lake that we thought might be worth sending an ROV down. And so we did that only to find that there was nothing there to worry about. It was a patch of Cara. Again, here's that spot in the middle of Brooks Lake, fairly defined, and nowhere else in the bottomlands of Brooks Lake and this fairly eutrophic lake did we find anything that we thought was worth sending an ROV down. And then there's a small little delta that comes out of Brooks Lake. There's about 5 different brooks that empty into this small lake. And we know where we could locate and find curly leaf pondweed. So how does that look in the optical data? And here, sure enough, we can see how it looks. And once we have a visual understanding of how it manifests itself and presents itself, we can then look elsewhere to see if there's more. And so once we find it, we get after it, we pull it out of the bottom. And we also, while we're there, make note of anything that might be there that's worth adding to our biodiversity project. And also these wind directions that we find, if there's EWM and it's washing up on the shoreline, we can find it. But in this case, we were fortunate that when the fall winds came and it tore apart some of the aquatic plants, that when you look at it up close, we found that it was nothing more than northern watermilfoil. I'm going to stop sharing my screen for just a moment, if I may. I think this will work. Kyla, is there a way for me to stop sharing?
You have stopped sharing, and now I just see you.
Okay. Hang on here. I don't see my stop sharing.
Maybe you see the recording?
Hang on, I found it. What I want to do now is play a video. Should work. Can you see that now?
Yes, we can see it. It just needs to be full screen.
There.
Yep, perfect.
I thought I would take some time and actually play some of these videos that you've seen in my slideshow as screenshots. So again, this is at 394 feet. And what we're seeing is the contours of the land and the shoreline, as well as the drop off. And one of the things that I like about this is that we kind of give you a feel for where we want to spend our time with the ROV. And if I were to just take a moment to say, all right, we're looking at this for the first time, I would stop the video and then I would screen shoot a rectangle around here. And I would say, this looks like something we should check out, this line of vegetation here. So what I'm going to do is take a screenshot of that, get the GPS coordinates, give that to Dennis. Dennis records where he's going to put the spot lock on his boat. He gets navigational aids to go to that spot, sets down his spot lock anchor system so we don't disturb any of the bottomlands. And from there, we start looking at sending the ROV up and down this area. And as we do that, we not only record the presence or absence of EWM, but we make note of all the fish, all the sponges, even bryozoans, anything that's living there, we make note of it and put it in a Google Earth with a location pin and then populate that pin with what's there. So that's pretty much the basis of what we do. I'll just play a little more of this video so you can get a feel for what we're seeing. If you look on the upper left of this video as it plays forward, there's really no need to make any of these sight. And you could argue that maybe there's something there that we want to see that we're not seeing because we're spending time over here. But likely this is not, if it's going to be a new crop of something invasive, that it'll be something that'll show up in future surveys. So as you see the video playing forward, you're also noting that the GPS coordinates are shifting and the compass readings on the video is shifting as well. But the one thing that tends to hold constant is the elevation above the waterline at 300, roughly 300 feet. Looks like Dennis started out high and brought the drone down to the desired height. What I'd like to do next, if I can do this, is show you some underwater drone, what we call ROV, of that same spot. So we're at a site, we'll call this site number 90. And so if you think about the numbering systems, we started with 38, we added more, and then we went to Fisher Lakes and added more. So we're at about 90 sites. What I like to do is take you underwater and show you the quality of camera work that can be displayed. I'll turn off the sound because you probably don't want to listen to a bunch of bubbles for the rest of the hour. So what I do is I move this scroll screen or scrolling tool on QuickTime Player to kind of get me down to the bottom. We're in about 19 feet, maybe 15 to 19 feet. We're still not picking up any vegetation. And now we're seeing our first view of what looks like Chara combined with some filamentous green algae. And then we ran across this beautiful colony of coontail. And if you watch the coontail come and go out of the screen, in fact, one of the beauties of the underwater ROV, if you need positive ID and you need a zoom in, our ROV pilot, Sean, really knows how to, if he sees something unique and interesting. He'll zoom in on it with the ROV. You can also see some fish that are swimming around the tops of this coontail and an occasional sprig of northern water milfoil. And I'm seeing some rock bass come into view. If I wanted to screenshot that and shoot that and put it in my folder for this particular site, I could definitively say that nobody could ever argue whether or not this is whatever. So here we see, as the ROV moves around, it's scaring around a school of perch, yellow perch. And then you can see some other species of aquatic plants starting to show up besides coontail. This is almost a monoculture of coontail, and it's really interesting to me that we have this much coontail here and nowhere else in the watershed. Of our 90 some sites, we've only found it once, and when we found it, it was robust. I don't know if you noticed at the top, a lot of times we watch the fish and not look at the plants, but we can come back and scrub this video again and again, which is nice. Because as you scrub it, you find that you might have missed something in the first round. So you can always freeze frame it, screen shoot it, and then move forward, freeze frame it. And you could even do fish counts. I've not done this, and we've always got the opportunity to extend the study beyond just what I've accomplished in this year. You can come back to this video, store it on an external hard drive, and you can come back and look at this again and again, because there might be something here that we're not seeing or paying attention to now, that if we come back to it and look at it and compare it to maybe future ROV work in this site, we can see what changes might be occurring. And so this is, again, the baseline study for what we're talking about. Let's see if we can pick up another species of fish. So far we've got rock bass, perch, and pumpkin seed. Notice the markings on the perch. They got these vertical bars on their sides that line up almost perfectly with the aquatic plants. So it gives them maximum camouflage from predation. And this looks like a pretty healthy crop of perch. And if you found this aquatic plant site and there were no fish at all, you'd say, well, maybe there's something going on with a die-off of fish, and you can start to question that and then come back to this video and decide whether this is going to be important for the future. Because, in year 2025, this is what we're seeing. What are we going to see in year 2029 when we revisit this site, or even in the following year? So we're hoping that as we take a look at these videos and make note of what's there, that we would hopefully see the same thing looking the same in the next, hopefully, decades to come, because this looks pretty healthy to me. All right, so I'm going to exit this screen, and I'm going to stop my sharing and maybe go into some Q&A. I know I'm a little bit early on my presentation, but I really enjoy the give and take of what people are thinking about and asking about. So looks like there's a fair number of people here who might want to chime in.
Definitely. Thank you so much, Rob, and everybody. You are welcome to turn on your camera or unmute yourself or throw a question in the chat if that's how you prefer. But yeah, please ask your questions.